Most skydivers jump off a plane flying 3.8 kilometers above the ground. But imagine jumping off something even higher, like the International Space Station. Unless you have a supersuit like Tony Stark, it's not gonna end well. But let's pretend Iron Man lends you one. Okay, ready? 3, 2, 1, jump! Wait, what? That's right, you won't fall straight down. In fact, it'll take you at least 2.5 years before you reach the surface. So what's going on? Height isn't the main reason your fall takes so long. In fact, if you fell like a normal skydiver, it would only take you about 2 hours. But the thing is, you don't fall straight down. You fall into orbit. The reason is speed. You see, the ISS might be called a station, but it's hardly stationary. It's actually moving 12 times faster than a jet fighter. If you shot anything at that speed on Earth, by the time it was about to hit the ground, it would miss. In the same way, the ISS isn't floating in space, it's falling towards Earth and missing. And when you jump off the ISS, you're initially moving at the same speed, so you end up in orbit too, at least for a while. Now, even though it's so high up, the ISS is pushing through a very thin atmosphere, so that friction against the atmosphere slows it down. So the station fires engines to maintain speed and keep from crashing into the Earth. But sadly, your supersuit doesn't come with engines strapped to your feet. This has 2 consequences. First, it means you can't maneuver and have to hope that any of those 13,000 chunks of space debris don't impale you. Second, without rockets to maintain your speed, it'll slow you down and spiral toward Earth. But it won't be quick. The Chinese space station Tiangong-1, for example, took about 2 years to fall out of orbit. On the ISS, you're higher up, so you'll take roughly 2.5 years. But once you strike the atmosphere, your long wait is over, and it's go time. As you re-enter, you have one goal: slow down. You're traveling at hypersonic speeds. So, if you deployed a parachute now, it'll shred to pieces. And that's not the only problem. Falling through the atmosphere at such breakneck speeds generates at least 8 Gs of force. That's 8 times the gravity you feel at sea level. And if you're falling feet first, that'll push the blood away from your brain and toward your feet. So you'll probably pass out. Unless you're one of those fighter pilots who train to withstand up to 5 Gs. Now, if you don't pass out, you may worry about the freezing temperatures up here. But it turns out your suit's more likely to melt than freeze. You know how you could warm your hands by rubbing them together? Now imagine your supersuit rubbing against air molecules in the atmosphere at least 6 times the speed of sound. You'll heat up to about 1,650 degrees Celsius, hot enough to melt iron. In fact, the heat is so intense, it strips electrons from their atoms, forming a pink plasma around you that will ultimately destroy your suit. If that's not enough of a problem, the drag will rip off your limbs. But thankfully, Tony Stark has your back, and somehow your supersuit holds, with you intact. At 41 kilometers up, you've now reached the world record for highest skydive. In 2014, Alan Eustace wore a pressurized spacesuit as he rode a balloon up to this height. He broke the sound barrier on his way down before deploying his parachute and landed about 15 minutes after the drop. But you'll be falling much faster than Eustace, about 3 times the speed of sound. So in reality, you're not going to slow down enough to safely deploy your chute. That's where Iron Man can help us one last time. By 1 kilometer up, you've reached the territory of ordinary skydivers who don't need fancy suits to survive. At this point, your parachute can do what it does best. And it's finally time to land softly.